Somasundaram Subbu. He's the category lead at AWS. Previously, a lot of experience in financial services at places like Scotiabank, BMO Financial, and he's going to be sharing with us today a little bit about security guardrails. So I'm going to go ahead and turn it over to you now. And while we're getting connected here, right, just a heads up for everybody in the audience, it turns out that when you switch to presenter view, you're given the presenter ball. It takes just a moment to unmute and figure all of that out. So we're going to go ahead and give him a moment. Looks like
hello.
Yeah, someone. There you go. I can hear you now.
Yeah, it just took a few seconds to unmute. Again, thanks for having me, Frank. This is a pleasure here. It looks like I accidentally clicked a couple of times. So yeah, Subbu, as Frank pointed out, I am a senior category leader in AWS. I've been with AWS for 4 years now. And during this time, I had the privilege to work with large enterprise customers to solve their security. In today's section, I'll be sharing some of the challenges and solutions based on my experience working with my customers. And of course, as the title states, it's security guardrails for specific to DevOps. And as a customer who's trying to do DevOps, and the major challenge is how do I strategize my access management to the environment?
Hey, Soma, sorry to interrupt. We're getting a little bit of static, a little bit of feedback here. We can hear you, but it sounds like maybe there might be a loose connection or a little bit of static coming across here that makes it a little choppy.
Okay, let me get that fixed right away. Thank you.
Yeah, so while we're waiting for him to connect back, so just to give you a little bit of a heads up, the next talk after this is going to be all about serverless security. The one after that is about threat detection and incident response. And then we'll have another talk after that on monitoring and threat hunting. And we're going to close out the day with a panel with 5 different participants, a couple of which whom you will have not heard from up to this point in the session. So just a reminder also that this is the first ever Cloud Security Solutions Forum, and with SANS and AWS Marketplace. So we have that freely available book, 365-page Cloud Security book available. The link is in the channel and chat room as well. Subba, you want to go ahead and do a quick sound check again?
Awesome. Yeah. Does it sound better, or how do you feel now?
Oh yeah, that makes a huge difference. Thank you so much.
This looks like the old school wired way works better.
Yeah.
Okay. So thanks again. Thanks for the patience. Again, going back to the agenda, to begin with, I will explain the challenge with access management when organizations utilize DevOps as an operating model to run their AWS environment. That's one of the primary challenges we will talk today. And I will walk you through one solution which uses access guardrails to reduce risk and gain confidence. I will also dive a little bit deeper in one guardrail, which is the preventative guardrail. And at the end, I'll point to some of the options you have in AWS Marketplace to implement some of the access management solutions. Okay. With no further delay, let's start to dive deeper in the access challenge when it comes to DevOps and implementing in an AWS cloud. So looking at DevOps, one of the main purpose for DevOps is to enable organizations to deliver applications and services at a high velocity. I really need to underscore high velocity here. This speed enables organizations to deliver features to their customer faster and also compete more effectively. I think one of the core objectives here is the speed and time to market. I think that's one of the main purpose organizations started to adopt DevOps, and so that they can modernize faster, get features out faster to the customers. But if you look from a business owner's standpoint, the owner would like to ensure the applications has been built with the right level of security and compliance and delivered at speed with low effort and high confidence. The low effort comes with automation, high confidence comes with ensuring the reliability, security, and everything is maintained. In some cases, however, we noticed security has been implemented as a gated approach, where a human would be performing the review to validate if there is the right level of access and if there is the right level of security established. This approach would definitely ensure that security and compliance is established. However, it might slow down the delivery speed and increase the time to market. This becomes counterproductive from the DevOps model where they want to move faster, get features out faster at a higher speed. So now let's look at the same scenario when it comes to how it works in the AWS world. Here, the top bar represents the CI/CD pipeline that are typically managed by DevOps teams. The bottom green bar and the side blue bar represents the governance, management, and observability capabilities that are required to successfully operate an AWS environment. As a first step, typically customers start to provision their AWS accounts. This includes like baselining the account, like ensuring that the Guardrail is enabled, config is enabled, and also having integrated with some of the solutions like access management, secrets management, log management, and also billing and cost management solutions. So Control Tower, AWS Control Tower is one of the services that provides this functionality to help customers to consistently provision AWS accounts and baseline some of these capabilities. The second stage here, the network deployment stage or foundational infrastructure deployment stage, this starts with deploying services such as VPC, which stands for Virtual Private Cloud, subnets, transit gateway, and other foundational network backbone that an application needs for communication or user needs to talk back to the on-prem services or to the cloud services within different environments. At this stage, some of the network security and API security components can also be set up to ensure the network security and perimeter security are well handled. This includes NACL, the network access control list, security groups, network IDS and IPS solutions such as Palo Altos, and also sometimes you may have third-party solutions that are implemented in a shared service, a shared network accounts such as. So once you have this account baselining and the network foundation set up, that's when the applications teams in the third stage, typically this can be full stack developers or the teams who manages their own resources, the AWS resources and the applications as a package to deploy and manage. So this could be a 3-tier stack team that they are deploying an Amazon EC2, EBS volumes, and Amazon RDS for their 3-tier stack application. Or this can be a serverless stack which uses Amazon's API gateway, Amazon Lambda, and Amazon DynamoDB to manage their serverless application stack. Again, the set of applications that are deployed by these teams could vary. For example, if your application team is managing a big data solution, they may be provisioning Amazon EMR, Athena, Redshift, and those type of tools and Amazon services. Again, this drastically changes by what the business is trying to accomplish. One of the critical factors that connects these are the access management layer. So the DevOps team has the right level of access to manage their individual resources or services that they manage. And the second part of it, for it to be successful, is the logging, so that you have the right level of governance, management, and observability established, so you can feel successful and confident in this environment. Now let's focus on the access management layer for today's session. Applying the right level of access plays a key role in the success of DevOps. The access for each of this individual pipeline, such as the account baselining pipeline, a resource pipeline, and a resource and application deployment pipelines and network pipelines, should be customized to ensure it has the access only to manage its resources that it supports. For example, a resource deployment pipeline should not have permissions to change resources provisioned by an account baselining pipeline. Similarly, a network deployment pipeline should not have permissions to update resources managed by an application teams that are application resources that are deployed by and managed by a different team. So unless if there is a special case scenario where there is an exception where there is an incident response scenario that they have to manage a resource. In addition, for deploying these resources, often these pipelines are required to build their own IAM principles so they can manage their own automation for application and database access purposes. So for example, here you can see as a part of account baselining, the human access role and additional automation roles are provisioned as a part of these pipelines. Similarly, the resource deployment pipeline might be provisioning roles, access, and permissions for applications to access the backend services or the data access for Amazon DynamoDB, Kinesis Stream, and Amazon EMR, and even interact with other application services hosted in same or different AWS environments. Now, what we need to have is we have to, with this requirement in mind, one of the question is, how do you enable DevOps team to securely provision their application resources on relevant IAM principles? Hence, our challenge is to enable DevOps team with the ability to provision IAM resources required for their application stack, at the same time, ensure the right level of security is maintained. That's one of our challenges that we need to solve. Okay. One of the solution is to enable an access guardrail for DevOps to reduce the risk of privilege escalation and enable segregation of duties. So the overall privilege acquired by a DevOps team is always under control. So let's start to dive deep here. This is a common diagram that illustrates the DevOps infinity band. It shows the different stages in DevOps workflow, such as plan, code, build, test, deploy, operate, and monitor. It also shows the different security controls and guardrails that can be implemented in each of the stages to ensure the appropriate security is implemented in the DevOps workflow. For example, applying a static code analysis in the build stage or dynamic analysis in the test stage and compliance checks in the monitoring stage. These are different security guardrails that can be implemented to ensure confidence. Well, let's convert this to access guardrails and see what are the options we have today. At a high level, we can break this down as a pre-deployment guardrail versus a post-deployment guardrail. The pre-deployment guardrails helps to ensure validations can be caught more proactively before the deployment is made. The post-deployment guardrails helps to prevent, detect, and remediate in a production environment in a more reactive fashion. But for us to successfully operate in an environment, you need to have both so that you can have the overall confidence. If you look from a DevOps engineer standpoint, as we said earlier, they need to achieve agility, and they may need permissions to perform build and deploy deployment tasks, right? So one of the foundational criteria is to ensure everything is codified and automated. So this includes infrastructure as a code and security as a code. At the same time, not just codifying is going to solve the problem. We need to ensure all the deployments are only done via the approved CI/CD pipeline and does not have other ways to change the resources unless approved by an approval process in an incident response scenario. Because once you establish a pipeline, then you have to reinforce the pipeline to ensure only the resources that are built by the pipeline are managed by the same pipeline. If you look from an access administrator point of view, one of the questions that's commonly asked is, how can they ensure the pipelines can only deploy the appropriate resources and meets least privilege access that's required for the pipeline or the DevOps teams using that pipeline? Adding a preventative guardrail, such as a condition-based policy, allows changes to resources based on specific conditions, in addition to the role-based access control that's already been established. This could include adding attributes such as environment variables, product types, product names, or application names, etc. This provides more confidence that specific pipelines can only access its own resources and not someone else's resources. This is quite often a common challenge when you have an environment which is shared across multiple application teams. Now that we have seen the preventative guardrails, let's look at the detective guardrails. In this case, this helps to ensure the permissions deployed by the pipelines does not violate least privilege access. For example, the security as code can be scanned by tools such as CFNGuard, CFNNAG, and other linting solutions. I've built my own homegrown linting solution as well to scan these templates to make sure these permissions are at the right level. For example, if you see a permission that has a ***, which means allow all, that can be denied from deploying. If you have a permissions to manage unauthorized resources, for example, if someone is deploying an IAM policy, which allows to manage someone else's resources, then you can deny that. And you can also deny permissions for that makes to perform unauthorized actions, such as deleting a CloudTrail turning off configure recorder, or deleting S3 bucket, which may have sensitive information. So these can be prevented in a directive fashion. Now that we have seen some of the controls from pre-deployment stage, now let's start looking at what's happening in the post-deployment stage. There can be preventative guardrails in the post-deployment stage as well. Unlike the preventative guardrails that are put in the pre-deployment stage, this is primarily focused on controlling the actions that are specific to this pipeline. The post-deployment guardrails are global controls that are applied at the account level or environment level, and it applies to all the IAM principles unless if there is a conditional exception established. So this ensures anyone, any pipeline, or any users accessing this environment can be protected. So some examples could include having a service control policy, often referred as SCP, that are applied at an organization unit level, root account level, or account level. You can also use permissions boundaries that are forced to apply to a broad set of roles based on some conditional criteria. That's also another options we have seen. So these helps you to prevent the production environment. Okay, now let's look at what we have from a directive controls perspective. So you can also apply similar directive controls, but that's as continuous scanning tools that can scan the environment for access compliance. You can set up your rules to ensure the least privilege access is established for all the IAM principles that are provisioned in this environment. You can also scan to detect for unused credentials and delete those credentials. If there are access keys and secret keys that are provisioned and you do not want that to be present in the environment, you can remove those access keys and secret keys. And if you see there are rules that do not follow corporate standards, corporate naming standards, or it's not assigned to the right centralized identity tool or access management tools, you can remove those rules that are not properly managed. So this can be continuously scanned, detected, and remediated. So last but not least, the responsive guardrails to perform the automated remediation when a violation is identified. Of course, this is also mandatory for you to be successful in a DevOps world, because once you detect something, you really want to remediate as well. However, this type of remediation has to be done cautiously so that when you're confident these remediation automations work or effectively without shutting down a production environment, you can implement those remediation automation. Some of these remediations can also be performed manually, such as when you have like incident response playbooks and runbooks. Some automated remediations examples could include decommissioning an unused credentials that's been sitting there for many days and removing the roles that are never used. So those things can be automatically remediated. Now that we saw the overall view of different type of guardrails, starting from the preventative detective in the pre-deployment stage, preventative detective and responsive in the post-deployment stage, we can start to dive deep on one guardrail here. Here, I'm picking the preventative guardrails, and I want to walk you through how it's implemented in some of the customers we had today. Okay, I'm sorry, there's a delay in the click. Yeah, so let's dive deep on this specific preventative guardrail in a post-deployment stage. So first and foremost, we need to start to group the controls that needs to be established in an organizations. This starts with organizing the controls into dedicated groups based on your business needs, based on your organizational structure or your application architecture or application needs. It could be compliance reasons too. For example, your business may just be operating in a specific set of regions or countries, or you're required to operate in a specific region to meet for compliance requirements. Similarly, you might be required to use only a specific set of services that meets your requirements or your corporate standards. So these can be grouped in their own buckets. Third guardrail is to protect the shared services that are applicable to many applications. For example, log aggregation, network hub, transit gateway, and other similar services should always be turned on and it needs to be protected. These are the shared services that needs to be protected. Guardrail 4 talks about the governance resources that should be protected. This can be CloudTrail, config, guard duty, and other vendor applications that are deployed in an EC2 instance. That needs to be protected as well. For example, you may have a Palo Alto running in an EC2 instance. We want to make sure no one turns off that Palo Alto instance. So those things need to be protected as well. Fifth guardrail ensures protection for data plane access. This ensures that no developers or engineers are able to access to the data layer. So you can control access to, for instance, S3, or someone's trying to make a backup of an EC2 or EBS volume. So you can have those protections in place. Guardrail 6 focuses on restricting some privilege actions that can be an elevated permission. It can be detrimental to the environment, or it can be detrimental to the actual data itself. For example, someone is trying to delete an S3 bucket or removing a production instance that's up and running. So those things can be prevented by ensuring those controls are denied, or those actions are denied. Having these multiple set of guardrails, one thing that it does is it allows the DevOps team to manage their own environment, and it actually gives more confidence to the access management team. Following shows some technology options that you can utilize to apply these guardrails. For example, we can use SCPs all the way from Guardrail to Guardrail 3, and you can use SCPs or permissions boundaries for Guardrail 4 and permissions boundaries for 5 and 6. Again, these technology options may change over time, or you may have new features and advanced features that you can apply to get the same controls that you would like to achieve. So always be prepared to update these technologies when new technology becomes available. So when you build this architecture, you have a mindset that you are able to change these guardrails in a more ad hoc way or a more modular way, so it doesn't impact the production or running systems. So you can change it quickly and to an advanced feature that's coming up in the future. So a common question that I often get is, who should be managing these guardrails? It really depends. It really depends on the organization size, organization structure, their cloud and DevOps maturity, and the nature of their business. This shows an example. Whatever I've displayed here is just an example where a cloud ops team, which quite often is referred as Cloud Center of Excellence team, they can be managing the guardrails that are primarily associated with infrastructure components, because they are provisioning the infrastructure and foundational account stuff. So they can manage those foundational guardrails. And the security teams can manage guardrails associated with the access control in the specific use case, so that the security team can feel confident that these controls are already in place, these guardrails are already in place, so they can confidently allow to nominate a delegated administrator within each DevOps, application DevOps team, or we can call it two pizza teams in Amazon, to manage their own access controls, to provision their resources within their environment. Okay, let's validate this. Okay, you could ask me, hey, how can I make sure this works? Let's assume that a user managed to get full permissions to the environment, like a star. These guardrails, it looks for if this environment has a region restriction, it automatically denies it. It automatically denies service restrictions. It protects the shared services. It protects the governance resources. It protects the data layer. It protects other privileged action. And then if you can have a resource tags that controls the resources that are deployed in the environment, that can also be applied. And finally, this specific user will only get the residual permissions that's it comes at the end of the access. So this enforces confidence and also reduces the blast radius in case of a compromise. And in a normal case, it's even better because we have other guardrails that's we have to go back and see. Let's not forget, we walked through a whole bunch of guardrails here. What we have seen here is only the preventative guardrails. If you combine the preventative and detective guardrails, which is already plugged into the DevOps pre-deployment stage, and you already have detective and responsive guardrails in the post-deployment stage, if you combine this with all the other guardrails, this will increase the overall confidence of this environment. These guardrails removes or reduces the manual reviews and approvals, and also allows the DevOps teams to focus on deploying at speed and scale. So that's why this guardrail-based model just allows you to give more confidence and reduces the number of gates that you need to establish. And of course, in some regulated environments, there may need to be some level of manual checks that needs to be done. So that can be minimized and allow the DevOps teams to move a lot more faster. Okay, so now that we have seen the number of guardrails and how it can be used, we just covered quite a bit, and hope you leave this webinar feeling confident about the next steps with security and access management strategy with DevOps. Some products discussed today and more are available in the AWS Marketplace. AWS Marketplace is a curated digital catalog service that simplifies software discovery, procurement, provisioning, management through features that speed up product evaluation, improve governance and cost transparency, and enhance control over software spend. We have a broad and deep selection of security solutions offered by hundreds of independent software vendors, spanning infrastructure security, logging and monitoring, identity access control, data protection, and more. So this goes back to the different guardrails I mentioned. You have preventative guardrails, detective guardrails, responsive guardrails. You might be able to find solutions for each of these guardrails from our marketplace. AWS Marketplace can enable you to receive quicker time to value, and thus the ROI with your third-party solution. Recent third-party research found that it takes an average of just 27 hours to find, buy, and deploy a solution through AWS Marketplace, compared to 52.4 hours through other procurement sources. That's an average time savings of 49%. This research also uncovered how AWS customers, such as yourself, felt about their AWS Marketplace purchasing experience compared to other sources. As you can see on the right, a few of these highest rated benefits include cloud readiness of the solution, time to value, and return of investments. AWS Marketplace is supported by a team of solution architects, a number of them spoke today, security experts, product specialists, and category leaders like mine, and other humans to help you connect with software and resources you need to prioritize your security operations in AWS. So you can ask, how do I get started now? There are a wide variety of security solutions available in AWS Marketplace. I've listed some of the key vendors here. Many of them offer support for creating efficiency within your SOC. When you're ready to buy, flexible pricing options such as free trial, pay-as-you-go, BIOL, and seller private offers help you to unlock best prices and meet budgetary needs. I would like to also announce a new AWS private marketplace feature that just launched. With private marketplace, buyers can curate a catalog of approved third-party softwares available in AWS Marketplace, allowing their organization's end user to purchase software within their internal policies and procedures from AWS Marketplace. Private marketplace remove the need for blanket security controls for procurement and unlock the ability for end users to subscribe to third-party software pre-approved within AWS Marketplace. AWS Marketplace now enables buyers to programmatically manage their private marketplace using a set of public accessible APIs. There is also multiple deployment options, helping you to customize software provisioning to fit your security policies. This is very applicable for the DevOps world. AWS Marketplace helps you to customize and provision software the way you need it. Here are just few we would like to highlight today, including SaaS, Amazon AMI, CloudFormation templates, and Amazon ECS way of provisioning. Okay. Again, we saw a lot today. I think I want to save, I'll give you a lot more time for questioning. Feel free to ask the questions that you have. I'm happy to dive a little bit deeper. And my email is here. Feel free to reach out to me if you have some detailed questions. I'm happy to provide my experience and share some feedback to you.
All right. Hey, thanks a lot. A lot of great information there. We have a few questions that have come in here. And you talked about this a little bit in terms of kind of your logical flow earlier, but what recommendations do you have for change management within DevOps in terms of the classic change management process and versus how DevOps is working now in terms of continuous development? What would you suggest to kind of bridge that gap?
Yeah, I think change management again, and now there are some modern ways of doing change management. I think we have, I've seen teams build solid Git workflows with peer reviews. And like I pointed out, there are automated guardrails, like automated tests that are built. I've seen teams every time they write a user story, they know that this is a specific capability they need to build. For that capability, they work with the security teams to build the security tests that are required for this capability, and also any unit tests that are required for this capability. So when they build this pipeline on the capabilities, they automatically start to work with security architects and others to build these test capabilities. So that kind of helps with the overall change management process. And in some cases, they integrate with change management tools to make sure those tracking is always enabled. So there is an entry for every change that's been made.
Great. Next question. You talked a little bit about the different teams. So you've got the DevOps team, the kind of the ops team, the security team, the application teams. What do you see in terms of kind of the trends, and how do organizations go about building out that RACI, who's responsible, accountable, consulted, informed, and dividing those shared responsibilities? Can you elaborate more on that?
100%. Yeah, I think this is where, like I pointed out, it really depends on how the type of the business they are in. I always work backwards from what is the customer trying to achieve as a business, right? And are they really trying to modernize so that they can quickly move features to their customers, or are they trying to just lift and shift, migrate their apps to the cloud? So every business has their own objectives. So aligning with the objective is number one. And second thing is the maturity. And like you pointed out, I think if there is an organization that has a smaller footprint, they want to work on DevOps world, the structure is going to be very different. If the whole organization is moving towards a DevOps world, and now you're talking about centralization, these guardrails can be centralized. For example, the Cloud Center of Excellence team, that can be centralized. So that's where it really depends on the org structure. And I've also seen some organizations try to adopt a product-based operating model. If they are adopting a product-based operating model, then a previously model such as service-based operating model, so it might change drastically how you structure your org. And I'm also seeing versus centralized versus decentralized approach, and it really varies based on the business and the org structure.
Yeah, makes sense. The next question here, in terms of, you're talking about the marketplace, AWS Marketplace. Is there any kind of guidance, templates, some sort of standards on what are the cloud security requirements that help you decide between a AWS native service versus a product that's available in the marketplace?
Yeah, so I will follow up on that. I'm not sure who has a question, so I'll follow up on that question. Feel free to email me. I'll get back to you with more details.
All right. Next question related to the guardrails. A couple questions related to that is, you had on the slide, you mentioned SCPs, service control policies. Are the guardrails typically implemented using service control policies?
Yeah, like I pointed out, so these guardrails can be done by a service control policy today. And in future, if you find another way to do it, you can do it differently as well. So again, I've been with AWS for 4 years, and SCP was not there back then. So we ended up using a different technology to achieve the same control. So now again, you may be shifting forward based on the new features and technology that's available. And based on the experience from last year, I've used SCPs. And again, there may be new features that's coming up, and you should be able to use that as well. So that's where the modularization come in play, how you group those controls, modularize it, deploy it. When there is a new feature or new technology that becomes available, you can push the same control in a different way. Again, it's all following DevOps principles.
Yeah. In the case of a violation of a guardrail, how do you how are those typically detected, and so that they could be remediated?
So, so again, that's now diving a little bit deeper on the technology space. Now, there are different ways to detect it. So you can use native solutions like CloudWatch events, config rules, and we also have solid third-party solutions like Dome9. They can continuously scan the environment. And again, now as a team, as a customer, you are required to put the rules in place saying that these are the violations that I consider in my environment. When these rules are established, so those rules can be scanned in the environment, and a notification can be sent to your ticketing system or SOC or email, whatever tools that fits your needs. And we have SNS topic to plug in to get those notifications as well.
Great. Hey, very last question. I think this will be a quick one. You mentioned the Cloud Center of Excellence earlier. Is how many people do you typically see in a Cloud Center of Excellence, and who are they? What do they do?
Yeah, so a Cloud Center of Excellence is when an organization starts to get to the cloud, and they may have a very small group of people who are the experts in the cloud. So they start to identify the top security experts in the cloud space, top reliability experts in the cloud space, top infrastructure experts in the cloud space. They bring them together and build this cloud center of excellence. And as a matter of fact, I used to be a part of this cloud center of excellence when I first built a cloud for a previous organization where I used to work for. And we build the cloud foundations together as cloud center of excellence. And in this process, we also try to train other teams and make resources available so that they can quickly catch up. So that helps with the organizational transformation. So the cloud center of excellence helps to move to the cloud and eventually train the rest of the organizations to start adopting the cloud as well.
Mm-hmm. All right. Well, excellent. Thank you so much for your presentation, everybody. Let's give him a virtual round of applause. We have the Slack channel available as well for any further follow-up. And yeah, with that, thank you very much.
Awesome. Thank you so much. Thanks for having me.